I'd like to bring an example of each of the three types of indeterminate forms I just discussed and show how to solve them. The overall theme of how to solve them will be always to change every indeterminate form into an indeterminate quotient. That way L'Hopital's rule actually applies. It always has to be the form of indeterminate quotient before L'Hopital's rule can be used. So, for instance, take an example of an indeterminate difference. So we take the limit as x approaches 0 from the right of 1 on x minus 1 on e to the x minus 1. Let's see what's going on here. As x approaches 0 from the right, this ratio approaches positive infinity, because again, it's always a positive ratio due to the fact that all the x values here are positive to the right of 0. But because the bottom's heading towards 0 and the top is fixed, the ratio just grows without bound. So the first ratio is infinite in its limit. And then I'm going to subtract off. What are we subtracting off? What is the second function approaching here? Well, 1 over e to the x minus 1 is very similar to this one. As x approaches 0 from the right, e to the x, right? E to the x approaches 1 from the right of 1. And that means that subtracting 1 from that will always be positive, but yet heading towards 0. So it's very similar to this case. I have a fixed positive value here. The denominator is always positive, yet approaching 0, so therefore that's also a positive infinite limit. But the overall difference of the two is unknown. I don't know what's happening here. So we want to apply L'Hopital's rule, but we can't apply it directly to the difference. We need to restructure this into a quotient if possible. So the difference is usually straightforward enough to deal with. Just combine the two ratios into one ratio. So if I give this e to the x minus 1 over e to the x minus 1, and I give this one x over x with common denominators, it should look something like e to the x minus 1 for that numerator minus x for that numerator all over the common denominator of x times e to the x minus 1. This should now be an indeterminate quotient. Let's just make sure. As x approaches 0 from the right, so I have e to the 0, which will be 1. 1 minus 1 is 0, minus what's heading towards 0 is 0. The top is now 0 for its limit, and the bottom is now a product, and it turns out that both of the factors down here are approaching 0. One would have been sufficient, but that's causing the bottom to approach 0. So this is now a 0, 0 indeterminate quotient, which is what we're hoping for, because we can now apply L'Hopital's rule. So I'll take the derivative of the top and bottom separately and reapply the limit to that quotient. So the derivative of e to the x minus 1 minus x is, of course, e to the x back again. The negative 1 is destroyed, and then minus 1 from here. And then in the denominator, we have a product rule. We have first times the derivative of the second plus the second times the derivative of the first. But times 1 here, right, for the derivative of the first really does nothing, so I'm not going to write it. All right, so we now have this. I'm going to clean up the bottom just a little bit. So this should be the same as the limit as x approaches 0 from the right of e to the x minus 1 over, if I combine the e to the x terms together and factor off e to the x, I'll have this, something like that. Okay, that's just the way I prefer to look at it. And it's not that important to simplify at that stage, but it makes sense to me. All right, so now let's see what happens as x goes to 0. As x goes to 0, I have 1 minus 1 is 0 again, and the bottom is 1 times 1. Well, that's 1 minus 1 is 0, so no good. But it is an indeterminate quotient again, so we can apply L'Hopital's rule a second time and see what happens. It might get even better. So x approaches 0 from the right of derivative e to the x minus 1 is e to the x back again, minus 1 destroyed. Down below, the negative 1 is destroyed, and we have a product rule to apply again. So we'll have the first times the derivative of the second is just 1, I'm not going to write it, plus second times derivative of the first, which is e to the x back again, of course. Okay, so now we can see this is getting better. We will now factor off e to the x from the top and the bottom. So we'll have limit as x approaches 0 from the right of e to the x over, factoring off e to the x, we'll have 1 plus x plus 1. So that should be x plus 2. These will cancel. And now as we apply the limit of x approaching 0, that means this heads toward the 0, which means we have a 2 stuck here. So we have 1 over 2 is our answer.